Today we're going to do something a little different. So using that blank piece of paper you have in front of you and a writing utensil, follow along and draw as I tell you the story of the tree of life. This story starts off with a young man who was out walking on a very hot day. While walking along on this hot day, the young individual came across a very unusual stone. The stone looked like it would hold seasonal water. And being hot, the young individual decided this would be just a wonderful spot to plant a big shade tree. Well, the young man could visualize the full-grown tree and imagine the wonderful shade it would provide. So the seed was planted and the tree grew over the years. Some young lovers carved a heart in the tree. But the tree grew anyway. And the tree branched and branched and branched until the tree became full grown. And when the old man returned to see his tree, it had bloomed and produced fruit, and these fruit were most unusual, grape-like clusters. And as the man stepped back and looked, he could see the tree was part of himself. Well, you know what? Well, flip your drawing end for end. That's right, this tree is part of all of us. It's our respiratory tree, our lungs, our respiratory system, the system that takes in O2 and gives off CO2. And us landlubbers, this is accomplished by breathing. Let's take a closer look at the upper respiratory system. That unusual rock, it's the nose. The nose has a number of functions. One of them is smell. Do you ever wonder why we say our feet smell and our nose runs? One of the jobs of the nose is to filter the air, and surprisingly enough, those nose hairs have very little to do with it. Actually, particles in the air are trapped by sticky mucus, but that's not the whole story. So as the air comes into your nose, it runs into these bumps in your nose called concha. And these concha, just like the Volkswagen pictured below, stir the air up. So the air is swirling around as it enters your nose from the outside. So the incoming air is buffeted around by these concha, or these bumps in your nasal cavity, and that swirling of the air is going to allow those particles a greater chance to land on the mucus, and once landed on the mucus, they're stuck. But where's the mucus go? Another important function of the nose is to warm the air. This is accomplished by the numerous blood vessels, small blood vessels called capillaries, that line the nasal cavity. And finally, the nose functions to add moisture to the air. It humidifies the air. Just like one might use a humidifier to add moisture to the room, your nose does the same thing by the large number of blood vessels and the mucus that surrounds the passage. Interestingly enough, earthworms get their oxygen through their skin, and just like our lungs must be moist for efficient transfer of the oxygen and carbon dioxide, so must the skin of an earthworm be moist. We all know what an earthworm that's not moist looks like, right? Yep, unhappy. After leaving the nose, the air will pass the pharynx. The pharynx is simply the back of the throat. It's that place at the back of your throat, no matter what you do or sound you make, you can't itch. It's the last place that air and food both share the same passageway. After the food goes down the esophagus, and of course the air will follow us on our trip. After leaving the pharynx, the air will enter the larynx. You can see your larynx on the outside of your neck. It's that bump on your neck. You know, the Adam's apple. It's also called the voice box, and it contains vocal cords, which are actually muscles. The larynx contains vocal cords, which can be relaxed to lower the voice or stretched to raise the voice up to a higher pitch. Something that happens to young men about this point is when they go through puberty, it'll cause a thickening of these vocal cords and the larynx also, your Adam's apple. And sometimes this can lead to that typical squeaking that you hear out of guys. It's because they're learning to adjust to the new vocal cords. Leaving the larynx, the air would next go through your trachea. Your trachea is your windpipe. If you place your hand on your throat, you can feel the windpipe. It kind of feels like a vacuum cleaner hose. Those rings that you feel are cartilage rings. They're C-shaped. They don't go entirely around the trachea, and these function to hold the trachea open. Leaving the trachea, the air will be divided into head to each lung. This will be going through the bronchi, a single bronchus, two bronchi. Well, not everything in the air is trapped by the nose. Some of it makes it by and makes it down to the bronchus, and below that to the bronchioles. So what happens to it? We were talking about the mucus in the nose. Obviously that can be spit out, blown out, or swallowed. And if it's swallowed, it contains bacteria. It goes to the stomach, and the stomach acid will take care of us. It turns out the entire system is lined by little hair-like sweepers. They act like Hawaiian dancers, all dancing in unison, to sweep a layer of mucus on the top of their little hair-like structure called cilia back to the mouth, up out of the lungs. So again, it can be spit out, blown out, or swallowed. Well, many things can happen to the respiratory system that can cause it to become irritated. Things that this simple mucus sweeping system won't take care of. Regardless of what causes redness and swelling and irritation, when it has that condition, we say that it's inflamed. And we indicate inflammation by using a suffix, itis. Itis meaning redness and swelling. So a couple of the ones that you may be familiar with are bronchitis, or you have a cough perhaps and your bronchi are irritated, or laryngitis, where you may lose your voice because of irritation, redness, and swelling in your larynx. Well, that concludes our tour of the upper respiratory system. Tune in next time when we'll cover the lower respiratory system, where exchanges are seldom a problem.